I'm David Smith, and my inquiry started like this. I was burning a candle in my house, and the wax had got burned down so far that I could no longer get my hand down in the candle to light the wick. And so what I did is I rolled a paper towel up and lit the end of the paper towel and stuck it down in there to light the wick with that, kind of extend out the distance I could reach. And what happened was the paper towel started to burn so fast that I had to drop it real quick. And it landed on the wax in the bottom of the candle, and it started to melt that wax. And then what I realized was that paper towel burned for a whole lot longer than I would have thought it normally would have burned. And so then I thought, well, maybe I could try dipping cotton balls in there and see how long they burn. So I did that on my own and thought it was a really cool relationship. And that's what led me to my question for this. My question was, how does the amount of wax added to a cotton ball affect the time it takes for that cotton ball to be totally burned up? And we'll go ahead and go to my prediction of what it would be. I thought it would be a logarithmic regression or a logarithmic relationship. And what that is, I actually have a picture here, is at first it increases really fast and it slowly tapers off the higher up it gets. So here's my amount of wax that I've added, and that's in grams, and the burn time in minutes that I've added. So the amount of wax is what I added to the cotton ball. I actually absorbed it into the cotton ball, which I will show in a video. And the burn time was how long it took from the time I lit the actual cotton ball to the time where it went out. And so at first I thought it would go really fast, and as I got more and more wax, it wouldn't burn that much quicker. It still increased, but not as fast. All right, so my independent variable would be the amount of wax that I added. The dependent variable would be that time that it would have taken to completely burn. And of course, it would be continuous data because I could change that amount of wax that I added. It didn't have to be 0.5 grams, 1 gram. It could be 0.75 grams. I could actually change that as much as I wanted. Now my equipment, I'll go ahead and read through the list. I needed a lighter, a stopwatch, cotton balls, and I used 18 cotton balls for this experiment. Candle wax, an actual candle for melting the wax over, and a spoon to melt the wax in. A freezer to cool the cotton balls quicker with the wax on them. A plate to cool them on. A knife to cut out the wax. A scale and envelopes to put the wax in, and then a pen to record my data. Now the procedure right here, I have a picture of the scale that I used, the knife and the candle. And what I do is I slowly scrape the wax into the tray, which was zeroed in prior, until I had 0.5 or 1, the amount of wax that I wanted. And I made sure that I had 3 amounts or 3 test groups for every weight of wax. Okay. Now, melting the wax in application, here's where I actually have that video. And I'll go ahead and play that video. Play it for you. Here I've measured out the wax in the different amounts, the 0.5, the 1 gram, 1.5, 2, and 2.5.
So he says that's what he's doing.
Using the wax over candles so that it can be absorbed into the cotton balls. I figured that would be the best way to make sure that all the wax is on the cotton balls by the time I actually burn the cotton balls. And now we are to the procedure. So what I did is I burned, like I said, three cotton balls for every amount of wax that I had. And here's me burning one. I would light with the lighter and start my stopwatch as soon as it started burning. And then when it went out, when the flame itself actually went out, is when I stopped the stopwatch, and then I recorded that data. And when I had the 3 different groups, what I did was I put 3 next to each other, and the actual cotton is very flammable. It'll catch really quick. So I take the lighter and I put it between the 3, and they'd all light right at the same time, and I'd start my stopwatch at the time, and then I'd spread them out so that they wouldn't affect the burn time of each other. That way I could time 3 at a time and then hit the lap button on my stopwatch every time that one would go out. And that way I could do all 3 at the same time. And I did the different weights of wax at different periods. Recording the data, here's where I have it recorded. On the left side going down, I have the control group, which is 0, and it goes all the way through the 2.5 grams of wax that I used. And then going across was each trial, those first 3 columns are the 3 trials. Right here, the 3 trials. And then here I did an actual average of those trials. Because as you can see, some of them would vary from almost a whole second difference. This is the 0.5 grams First one I did only had 5-second burn time, all the way to a little bit over 6-second burn time. So by doing an average of those, that helped weed out that variation in results. Here's a graph, I actually graphed the data that I had. Here's the first cotton ball without any wax on it, so 0 wax. And it came up very much like a logarithmic pattern that I had expected. I'm going to go to the next one. With the regression, I was not able to do a logarithmic regression because at time t equals 0, you cannot plug that into a logarithmic function. So for me to actually have done that, I would have had to drop that one off, which I did do. But here, it's a quartic regression that I did, and it follows it very closely. But in the long run, the pattern is not the same. A logarithmic pattern continues out, whereas this one is going to do a much different pattern than that. I actually have the actual equation, which I'll write down on the board for you guys to see. I'll just read it. Okay, it's about 5 plus 1.899 times the natural log of x. And the R for that, the correlation of coefficient, was 0.985. So it was very close to modeling what the data actually would have been. Now what I've learned, I talked about on the second one, that I needed to have a larger amount of trials to see how it affects it in the long run. I didn't know if maybe once I had a ton of wax, if that would have tapered down, or if it would have continued up in that logarithmic pattern. And also, the regression can't have 0 in it, so I learned that I had to change that as well. And that's that. I do have a video of me burning one of the cotton balls, which I'll show.
Alright, I'm about to burn one of my control group cotton balls. This has no wax on it. I've got a stopwatch here to time it. I'm going to do 3 different cotton balls per amount of wax. I'm going to also burn 3 different control group cotton balls as well. And here goes the first one. I'm going to wait until the cotton ball actually totally burns out. And the flame officially goes out. It's getting smaller.
Like I said, this one has no wax on it.
And the flame is now out. And it's about to go out right now.
I didn't blow any of them out.
We're at 50 seconds. With the flame. Out.
There we go.
1 minute and 2 seconds. And now I'll burn 2 more of those, but I don't have those on film.
Okay. Yeah, I didn't want to record every single one because it started taking 5 minutes long, and that would have kind of made my presentation take longer than it needed. All right, that's my presentation. So I accepted my hypothesis.
So you said that you couldn't get a logarithmic equation, then you read us one, so where did you get it?
I ended up dropping off that first one where I had 0 as one of my x values. T
And there's nothing wrong with that. Nothing wrong with that. Much preferred than trying to fit it to what you know it doesn't fit.
Yeah. And it fit very much that first graph I showed, my hypothesis, it really did. It fit
Yeah.
exactly that all the
You
data.
can drop that other one off, because
Yeah,
how many points does it take to get a line?
2.
2. I can make 2 points fit that too if I want to. I can make 3 points fit it. So you can drop out one that, and you'll be okay.
The only thing was the logarithmic function itself. I mean, I knew that with this graph, like the equation I actually gave, it had 4.9 plus, and then the logarithmic part of that equation. And for mine, when t equals 0, or when the amount of wax equals 0, it was actually positive. It wasn't negative like a linear function would have been, a logarithmic function would have been.
Roll won't come to an end.
Yeah.
Did you have any trouble, because did you burn it outside? Did you have any trouble with wind or anything?
I did. When I first started the project, I didn't have trouble with wind, but by the time I was doing my last ones, I had built up, I had a cooler and a trash can and some lawn chairs. Yeah, I did it towards the end, so I had to build that up to help block out the wind. So by the end of it, I had a floor built up around it, which basically fixed that problem.
So that's the traffic that we was hearing on the video.
Yeah,
Oh, you burned it, yeah, all right.
traffic or waiting, yeah. Any other questions?